Hi everyone and welcome to the new video. Fluorescent lamps have a very long history. They were invented in the 40s and they are still widely used today. Fluorescent lamps even become the part of the popular culture, and the flickering of these lamps we can often see in the horror movies. But did you ever wonder how the fluorescent lamp actually works? Interestingly, the physics behind is really fascinating. In this video I will show you several fun experiments with the fluorescent lamps and we will actually see how it works. And obviously everyone can read in the Wikipedia how the fluorescent lamp works, so instead I will do it differently. I will test every component separately and we will see how it works step by step. Without further ado, let's get into it. As a first step, let's start with the basics, and here I have a fluorescent lamp. You probably saw large fluorescent tubes on the ceiling or in the supermarkets, but they are just too long and not convenient to put on the desk, so I took a small one. It was taken from a portable lamp. This tube is smaller, but its functionality is still the same. I am testing this particular tube for the first time, so I have no idea if it works. We will figure it out together. Before we begin, a bit of theory. From the physics perspective, this tube is a gas discharge tube. It is filled with a low pressure gas. It is probably argon with a bit of mercury. And we know that the low pressure gas can glow in the high voltage. So as a first test I will connect a high voltage generator to this tube and we will see what happens. This is a cheap high voltage generator that I bought on Amazon. I did a separate video about it. If you didn't watch this, you are welcome to do it, it's fun. This generator requires only 5-10 volts input and it can generate about 10,000 volts as an output. As we can see, I am turning it on and we can see a spark here, so it works. And you can pause the video and think what will happen if I connect it to a fluorescent lamp. While you are thinking, I am connecting the wires. And let's turn it on. And as we can see, the lamp works. And now we need to understand how it works. As I mentioned before, the lamp has a low pressure gas inside, and the process actually has two stages. First, the fast moving electrons hit the mercury atoms. These atoms get excited and they release the light. But this light is not visible yet, it is ultraviolet. How can we see it then? The second stage of this process includes this white phosphor coating. When the ultraviolet light hits the phosphor coating, it emits the visible light. And as a final result, we can see this lamp glowing in the normal visible light. By the way, do you know what will happen if we have no phosphor coating? Watch this video until the end, I will show it later. So, as we can see, despite the small size of the lamp, there are interesting physics processes going inside. It's a real quantum physics in action on your desk. And by the way, as we can see, I connected only 2 wires to the lamp, but can we use less wires? 1 or maybe 0? Indeed we can. I can use a high voltage Tesla Coil generator which produces a high intensity electromagnetic field, and the lamp can glow in this field as well. Let's see it. So I'm disconnecting all the wires and I'm connecting the Tesla Coil. This is a cheap Tesla Coil from Amazon. It costs about $5–10. I did a review of it, it was fun. If you did not see it yet, feel free to watch it. And now let's turn it on. And as we can see, the lamp works. As we can see, there are no wires, I'm just holding the lamp in the hand and we can see the light. How on earth does it work? Glowing of the fluorescent lamp in the high intensity field of the Tesla Coil is a commonly used trick. We can see it often in the Tesla Coil demonstration, and it looks fun indeed. Of course, there is no magic inside. A Tesla Coil is just a source of the high-intensity electromagnetic field, and this field speeds up the electrons in the gas, and the further process is actually the same. Electrons hit the atoms, atoms emit the ultraviolet light, and then ultraviolet light makes the phosphor glows. And as a final result, we can see a light. By the way, as a fun joke, I asked the AI to make the video of the electron hitting the atom, and it generates me that. And I must say, it looks fun, but it is a garbage and it doesn't look like that. In the reality, the process is different. When the electron hits the atom, one of the electrons in the atom is moving to a higher energy state. But it does not stay there for long and it goes back, and in the process it emits the photon. The further process we already know. The photons of the ultraviolet light hits the phosphor and the phosphor glows in the visible light. So it absolutely doesn't look like that. Please don't trust AI generated videos. And by the way, by using different types of phosphors, manufacturer could use different types of the fluorescent lamps like warm white or cold white and so on. So it was widely used, and only now these lamps are slowly replacing by the LEDs. And as we can see, the physics of the process is exciting, and the fun thing is that we can do these experiments with a very cheap equipment like $5–10 from Amazon, so everyone can do it. And now let's go forward and see how the ballast works. And here I have a ballast. We cannot see what is inside, but technically it is just a large coil with a lot of wire. And from the physics perspective, it has two important properties. First, it has a big resistance, so it limits the current. Without it, the current through the gas will be too high and the lamp will be destroyed. And second, because of the high inductance, this coil stores a lot of electromagnetic energy. When the wire is disconnected, this energy is released in the form of the high voltage peak. Let's now see how it works. First, I will measure the parameters, and I'm connecting the LC meter to the ballast. And as we can see, the inductance is really high, is 1.5 Henry. The resistance is also high, and it is about 50 ohms, so this coil has a lot of wire. And now let's see how the ballast works. As a simple experiment, I am taking the breadboard and I am connecting the neon light bulb. These light bulbs are often used in the power sockets, and they usually require about 90 volts. And here I have a small 1.5 volts battery. This is just a standard battery, nothing special. And will I be able to power this light bulb with this battery? What do you think? And now watch carefully, I am connecting this battery to a breadboard. And as we can see, when I disconnect the wire, the neon light bulb is flashing. How is it possible if the battery voltage is only 1.5 volts and this neon light bulb requires about 100 volts? Well, as you can guess, the secret ingredient is a ballast. When I am disconnecting the wire, the ballast releases the stored energy in the form of the high voltage peak. And as we can see, despite the fact that the battery is only 1.5 volts, the voltage is enough to turn on the light bulb, which requires about 100 volts. And how high is this voltage? Let's connect the oscilloscope and figure it out. And now I'm connecting the oscilloscope, and I'm turning on off the lamp. And as we can see, the result is amazing. It is hard to see on the camera, but the highest voltage I saw is 295 volts. So this simple ballast, which has practically no electronics, it's only a big coil. It has no high-tech components, no microcontroller, no firmware, no subscription or stupid security updates, it's just a coil. As we can see on the screen, this ballast turns 1.5 volts to almost 300 volts. Now we can understand how the fluorescent lamp works with a grid voltage, which is relatively low. As we saw before, the fluorescent lamps requires a high voltage to start, and now we know that the ballast can produce this high voltage. When I disconnect the wire, there is a large peak. But who is disconnecting the wire on the real lamp? And now let me introduce the last important component, the starter. Okay, at this moment we did a test with a 1.5 volts battery, and now let's connect the lamp to the real grid. And as we can see, I connected the light bulb and I connected the ballast in series, and it is connected to the grid voltage. You can pause the video for a moment and think, will it work? And I'm turning the power on. And as we can see, nothing happens. This is expected because the grid voltage is not high enough to ionize the tube. And the circuit is actually not connected, so the ballast cannot also produce the voltage peak. So can we turn this lamp on? We actually can, and I will show how, but please don't do it like this. Here I have a long piece of wire. And now I'm gently connecting two pins on the lamp. And as we can see, it works. How can it be? To understand the process, let's see the schematic. The lamp has two spirals inside and they have a double purpose. First, when all four pins are connected, the current can go through and the ballast can work. And second, a hot spiral is a source of additional electrons, so it makes the start easier. And the process here is generally the same as I did with a small battery. When I disconnect the wires, the ballast generates a high voltage peak, it ionizes the gas, and then lamp continues to glow. When the gas in the lamp is already ionized, it has a low resistance and there is no need for high voltage anymore. The lamp can continue to glow without these two wires. And as we can see, the lamp works if we connect two wires together, but can we automate this process? Indeed we can, and engineers in the past has created the starter. Let's see how it works. Okay, now let me show the last component, the starter. And as we can see, it is a small gas discharge tube. It is like a small neon light bulb. And its purpose is exactly what I did with the wire, to connect the lamp for a short time. So how does it work? The process is actually interesting, especially nowadays when almost every logic is implemented with a microcontroller, with the firmware updates, etc. And here we can see only several metal components without any electronics. So how does it work? When the circuit is powered on, the gas in the starter became ionized. It becomes warmer and the special metals start bending and the contacts touch each other. And when two contacts touch each other, the temperature drops and the circuit is disconnected again. This short connection is enough for the lamp to start. When the lamp started, its voltage is lower and the starter doesn't work anymore. So it works only once. And now I'm connecting the wires and let's see how it works. And as we can see, it works. First, the starter glows for a short time. Then when the circuit is disconnected, the ballast produces the high voltage peak. This peak is enough to ionize the gas in the lamp. And finally, the lamp starts to glow. Let's see it again. Watch carefully to this starter. As we can see, the process is fully automated. It's fun to see how it works. You can also see a final connection diagram on the screen. As we can see, the starter is connected where I used the wires before. And now I will use a macro lens and we will see it in more detail. So as we can see, it works and it's interesting to look at it. Now you know how the fluorescent lamp starter works, and as a next joke I asked AI to generate the video of the lamp starter. And just for fun I will show you how it looks. It is ridiculously badly incorrect, but it is fun to see it. Enjoy! So again, don't trust AI generated videos. I was actually happy with these results. It means that there is a space for content creators, for people who are doing real things and who are testing the real hardware. So if you are watching this video and you are supporting real people, it is nice. Not everything can be generated with the AI prompt. And now, as I promised, I will show the process inside the fluorescent lamp, so you will be able to see the spirals inside and how do they glow. And to do this I will use another lamp without phosphor coating. I already explained at the beginning that the fluorescent lamp has a low pressure gas inside. The gas glows in UV and there is a phosphor coating that converts UV to the visible light. But can we actually see it? Indeed we can. And for this test I will take a special fluorescent lamp. First let's see how it looks and then I will turn it on. And as we can see, this lamp practically looks as a standard fluorescent lamp, but there is a big difference. It is transparent and it has no phosphor coating. Apparently this glass can also be special and it is transparent not only for the visible but also for the UV light. This lamp gives us a good opportunity to see what is inside. But before I turn it on I must give a warning. This lamp is specially made for disinfection. It produces UVC light which is dangerous for the cells, for the DNA. So you should use a protection glasses when you turn this lamp on. I used this lamp for a short time, maybe with a 5% of intensity. And even after that I was feeling discomfort in my eyes for like about half an hour, so don't do it like this. And now we can clearly see what is inside the lamp. As we can see, it is transparent. Of course we cannot see the gas. We can also see two spirals. And as we already know, they are used to start the lamp. And now let's do it, let's turn it on. Now I connected the wires. The connection diagram is the same as before. The only difference is that the lamp has another shape. And as we can see, the starter is blinking, but the lamp doesn't turn on. Well, apparently my ballast is not powerful enough for this long lamp. The role of the ballast is to produce a high voltage peak, and the bigger the lamp, the more voltage we need to ionize the gas. So previously I used the short lamp and this one is much bigger. But at least we can clearly see the spirals glowing. I can now show it in slow motion again. So this ballast is not powerful enough to turn on the lamp, but I have a plan B. I will use a small Tesla coil to ionize the gas and we will see how it glows. Now I'm turning on the Tesla coil and as we can see the gas is glowing. And here we can also see ionized gas around the spirals, so it is interesting to see how it works. And again I will repeat that you should be careful with such an experiments. Mostly this lamp is producing the dangerous UVC light. Here our eyes can also see a very small visible part of the spectrum. These lamps are used for disinfection, so they are designed to kill the cells. So it's better to use the protection for your skin and also for your eyes. But still it is beautiful and it is nice to see how the gas glows. And now, as a bonus for the viewers patient enough to view until this point, I will show another fluorescent lamp. It is a portable lamp, it works from 12 volts and it was made for car owners. It is a vintage lamp, probably from the 80s or from the 90s. And it has no ballast and no starter. Let's see how it works. Okay, let's first see what do we have at the box. And as we can see, it is a portable fluorescent lantern, so it is not designed to work with a grid voltage. It can work with the batteries that can be installed inside, or there are also clamps for the car battery, so it can operate from 12 volts. Alas, this lantern was damaged by post-delivery, so I cannot use it directly, but I can take a PCB and I can run it separately. Let's see how it works. Alas, as we can see, the plastic is damaged and it is beyond repair. It cracked in several places. And here we can see what is inside. First there is a long wire and there are clamps, apparently for the car battery. And this is a fluorescent lamp. I already used the lamp in this video, so we know that it works. Here is the battery compartment. I don't know the battery type UN1. Is it 3 volts or 1.5 volts? If the voltage of the battery is 1.5 volts, then the total can be 6 volts. Or if it is a special battery for 3 volts, then the total voltage will be 12 volts. But considering the car clamps, I can guess that this lantern can work from 12 volts. There should be no problem with that. Then we also have a single transistor. Interestingly, the reflector is also used as a heatsink, so the manufacturer has reduced the costs, but technically why not? Apparently it's a very simple generator with one transistor only. And here we have a small PCB with only passive components and the transformer. So apparently the driver of this lamp is made on a single transistor and it has a high voltage transformer that transforms 12 volts to maybe 1000 volts, and technically that is it. That is all the schematic. If you want to analyze the schematic, I will show pictures of the front and of the back side. You can pause the video and copy it. And now let's turn it on. Now I'm connecting the power supply to the board. I set it to 12 volts. And as we can see, it works. As we can see, there is no starter here, so there is no flickering at the start. The generation starts immediately. And also it's the same for the modern electronic ballasts. And I also became curious about the power consumption. So now I'm connecting the multimeter. And as we can see, with the 12 volts, the power consumption is about half amp. So the total power is about 6 watts. And funny enough, when I already finished this test, I saw a 6 watts power consumption written on the box, so I can confirm that it is true. And that's it for this video. Thanks for watching. I hope you learned something new. If you want to see more tests about different lamps, write in the comments below and maybe I will do a separate test. What is your favorite light source? Is it LED lamp or maybe incandescent or halogen or high pressure sodium? I will be curious to know. Write in the comments below. I also did the test of the spectroscope where you can see the spectrum of the fluorescent lamps. Feel free to watch it. You are also welcome to visit my Patreon page. This support helps me to buy things like this for testing. Thanks for watching and see you next time.